Hi, this is Herb Shapiro with the Dr. Vax channel. And today we're going to talk about empowerment. Yes, we are going to design a fascinating toy you can use to play with your kids or your grandchildren or keep on your desk for when you're bored. But more importantly, we're going to recapture that creativity everyone has as a child. I'm a lucky guy with 4 grown children and a gaggle of grandchildren. And when I watch my grandchildren, they're always building things. They're building doll houses, or they're building ramps for their trucks, or they're digging in the mud, or they're making a fort out of Amazon boxes. They're always creating. Now, isn't it fascinating that at some point, many of us lose that ability? We stop creating. We stop imagining. We think we have to go to the store or online to buy everything we use. Well, I am here today to prove that anyone can learn how to create again. With the revolution of desktop manufacturing, you can design and build your own toys. And that's what we're going to talk about today. So stay tuned and let's learn something together. Okay, folks, before we get started today, I'm going to issue you a challenge. I don't think these connectors are perfect. I think they can be better. I want you to watch the video, look at the different types, watch all the way to the end because you'll see the different kinds I tried, and then I want to challenge you to make them better. So the model, the actual CAD model for these on Tinkercad is publicly available. I have a link down below. And you can go to forum.drvax.com and you can discuss this with people. Let's create the best Popsticks so that over this coming summer, all of our kids and grandchildren can play with a fascinating new toy. Now, a lot of what I'm going to be covering today is close-up work, and I'm at the age where my glasses don't work for close things as well for me anymore. So I'm going to actually take the liberty of taking my glasses off for the rest of this video because I'll be looking at the screen and I'll be looking at things we design. Now, today the challenge is very simple. How do we turn these very inexpensive popsicle sticks? I bought a giant box of these online for like $9. I think it was 1,000 popsicle sticks. You might have a bunch of them pretty soon as the weather gets warmer. How do we turn these into toys? Toys that remind me of Tinker toys or other construction toys. Well, what we need is some type of connector. Some type of connector that we can use to connect together various sticks in various orientations, and that we can use to build things. So we need to build a connector to do this. Now, about 2 years ago, I created a series of individual connectors. I called them Popstick connectors. And I published them in a video and I put them on Thingiverse. The challenge today is, can we create one universal connector that can be used for all of our purposes? And the result is being able to build things inexpensively with popsicle sticks. Now, to get started, we need to understand the characteristics and limitations of 3D printing using extruded plastic filament, FDM printing, which is the style of printer we're going to use for this design. And to do that, we're going to use a model I created a long time ago for a series of videos on supports and when you need to use supports and when you don't. But let's start with an even more basic concept. Let's model the behavior of a 3D printer. So I have a print bed here. And let's assume this piece of string is, in essence, my extruded filament. Now I can take this piece of string and I can lay it on this print bed in any design I want. The filaments can cross each other, they can go in straight lines, they can go in curved lines. But let's assume instead of being supported by the print bed, I had two posts I'd already printed. And I want to take my piece of filament and connect it between those two posts. Well, watch what happens. See how it droops in the middle? That's going to happen to hot filament. It's not going to stay straight. It's going to droop in the middle. So the way you resolve that is when you have a model with an overhang. This is considered an overhang here. You put supports under it. And your printer can create those supports. Let's look at a picture on the screen of that. And you'll see here the supports underneath. Now, it's clear in a horizontal overhang that you need supports. But when exactly do you need supports? Well, you need those supports depending on the angle you're trying to extrude. Because verticals, see the column in the middle? Verticals print without any problem. In fact, this column that's at about a 40-degree angle would print fine. This, however, would not, would require supports. And generally, when the angle here between this point and this point, when that angle is over about 60 degrees, you need supports. When you're printing a model, it may be self-supporting depending on the orientation. So let's take this round disc here. This printed terribly. And the reason is that I was printing it flat. And there was an opening. This was, in essence, two discs with an opening between them and legs in the corners. You'll see here where the middle overhangs the bottom disc. Where the top disc overhangs the bottom disc, there's no support. And the end result, and I'll show you a close-up picture of this, is this very ugly looking print where you had strings here in the middle that didn't print properly. Now, if I had printed it this way, there wouldn't have been any overhang between the layers. However, when I print a model like this, here's an example vertically, these openings are fine, this opening is fine, but the opening in here, see that little horizontal opening? Once again, I'll show you a close-up. That's an overhang, and that drooped. So we need to take all of these factors into consideration when we're printing our model. Now, another factor is going to be speed. The more plastic we have in our model, these connectors print much faster than these connectors. The more plastic, the slower they'll print. Orientation also matters. The print head moves much more quickly this way than when it's shifting between layers. So if I print this flat, it takes, about 20 minutes to print. If I print it vertically, it takes about 40 minutes to print. Now, those are tunable parameters, but they all will impact your design. So when designing for 3D printers, you need to think about the characteristics of the material. You need to think about overhangs, whether you're going to need support, and the orientation you're going to print it in. Now, as I mentioned earlier, one of the ways to print a large bridge like this is to have the printer add supports underneath. In fact, I printed this model flat. I'll show you a close-up. And I added supports automatically. What I found is there was no way to get the supports out. The supports between the layers were so tight that they're not removable. So that's not a successful design. So let's look at how I came up with this design, and we'll start now in Tinkercad. If you look here on the screen, you'll see there are a bunch of different designs here over time. We're going to create a brand new one. And the first thing we need to do is we need to manufacture a tool. What do I mean by that? Well, objects that you create in CAD programs that are used to carve or manipulate other objects are called tools. What tool do we need? We need a popsicle stick, because this has to be able to fit in the different openings, in the different holes of this particular model. And so we're going to create first a popsicle stick and then use it to cut out the other openings in our models. To do that, I need the dimensions of the popsicle stick. Now I can measure it with a ruler, and this is about 10 millimeters by, I don't know, 2 or 3, but it's very hard to measure small measurements with a ruler. A caliper or a micrometer is a much better tool. You can get these actually on Amazon for probably 15 bucks. And the ones we use at home don't have to be that accurate. A really accurate one could be quite a bit more money. But let's look at the dimension here. And we'll take a look at this together. Let me look at it this way. So that's just a little bit over 2 millimeters. Then we have the other dimension. And the other dimension here is about 9.25. That's going to be less critical. And we're actually going to make that about 10. So we're going to make a tool that's 2 by 10, and the length doesn't matter. Let's go back to Tinkercad and do that. So we're going to drag in a box here. And we want the dimension, the height, to be 2.1 millimeters. We want the depth to be, we'll make a little bigger, 12, because having that a little bigger won't hurt anything. We'll make that 12. And then let's stretch it out. And unfortunately, I think I changed some of the other ones. So 2.1, that's still good. And this we're going to make 12. And now we have a tool. How do we use this tool? Well, let's say we wanted to make a connector that was a cylinder. Okay, and we'll look at that here. Well, I'm going to want to use this tool to cut out this cylinder. Well, how do I do that? It's sometimes hard to move things around in 3D space here. So what I can do is I can go to the top view, and then I'm going to move down here. And this is not a tutorial on Tinkercad. I'm going to link a whole bunch of them below. And we'll move this up here. And then I could go back to a 3D view. And that looks about right. But if I group those together, I just get a shape like that. That's not what we want. Instead, I'm going to make my tool, by clicking in open space and clicking on the tool, a hole. And now, if I group those together, we'll see I have a slot in the bottom of my disk. Here we go. But that's not what we want. If this was going to be a round connector, we would want it to be a little different than that. So I'm going to ungroup. First, let me make this, about 7 high. And now let me show you a very interesting trick. I'm going to select both these so they're grouped together, and I'm going to click on Align. And now I'm going to align on the center in that direction, on the center in this direction, and the center in this direction. Now, I'm going to group them together. And we've just made our first popsicle stick connector. Pretty simple. Now you'll notice that this is not completely round. So let me ungroup it very quickly. Select a space on the background, so we deselect. Select this. I'm going to say sides is a bigger number. That impacts how round a cylinder is. So let me group that together. So now what would I do? Well, the next thing I would do is I'd print one. And in fact, I started by printing these little squares, and I adjusted the thicknesses that I needed to make this so it slides, but it has good friction. So that's how I ended up with 2.1 millimeters. So let's look at how we turn this round shape into a more sophisticated shape. So I'm going to start by ungrouping. And let me start by actually making the length here a little shorter. Let's make it about 60, just so it's easier to work with. Whoops, changed the wrong one. So let me select just the tool, and I'm going to make the length of the tool about 60, so it's easier to work with. And then I'll move it over a little bit. Now, what if I want to also slice through in the other direction? So you can see on this one, there's slots in this direction and the other direction. Well, the first thing I'm actually going to do is select my cylinder, and I'm going to make it a little bigger. Let's make it 40 by 40. And we'll move it over here a little bit. And that's approximately right. And now I want to take my tool and duplicate it and rotate it. So I select the tool right there. I hit Command D to duplicate. And then see this little arrow here? Well, I'm going to hold down Command and rotate this around until I get it to 90. Now, here's the trick. I'm going to group them all. I'm going to click on Align and make sure they're all aligned in all of the different directions. See how it's all centered now? I can zoom out so make it easier to select again. Let me select the whole thing and group it. And now we have a disc with multiple holes, similar to this disc here. Now, let's say I wanted to make a slot going vertically. Well, I ungroup it. I take my tool, Command D, I duplicate it. And now, this time, I'm going to, and I'm holding Shift down, and I was actually wrong before, because Shift will go on the actual angles, the precise 45-90 degree angle. I move that to the middle. Now that should be perfect, but just to be sure, and I'm going to use Align and make sure they're all aligned in the proper position. They are. Now we can group it together. And there, I basically created this connector. Now I made one other change in this connector. You'll see there's an X in the middle. We'll talk about that in a minute. Okay, let's go back now and select the one I ultimately made, and let me show you how that's constructed. Then I want to talk about all of the individual models I tried and why they worked or they didn't work, so we can learn some more about design. Okay, let's look at this model. I'm going to zoom in, and you can see this model has slots going all the way through horizontally and a single slot on the top. Now, we will talk in just a couple minutes about why there's a single slot on the top, but let me ungroup this so you can see how I constructed it. So what you'll see is I used here a disc. Let me color that a color so you can see it. I used here a disc instead of the straight bar. It's still 2.1 millimeters high. And the reason I used a disc is that gave me a nice opening at the right angle so that I could really take and put multiple sticks in at the same time. And then let's take this item and ungroup it one more time. You'll see I layered two boxes on top of each other. Why'd I do that? Well, because I'm going to print it this way, and this box doesn't have to be the full width, but if I stop it part way down, what does that create? It creates an overhang, and I'd have to print it with supports. Okay, now let's go look at the series of models that I used here and go through and explain why I rejected them. So the first one I used was this rectangle. And it had slots on both sides and on both ends and a single slot in the top. And it worked pretty well when connecting things in this direction or in this direction. But if I wanted to connect in this direction and in this direction at the same time, sometimes the sticks didn't hold very well because they knocked into each other. So the next one I tried was the round one, and I showed you that the round one didn't have enough material. Then I tried a bigger round one. The problem with the bigger round one was I had the problem of overhangs. Why? I couldn't print it like this. To print it like this, I would have to add supports or it would move. It wouldn't stay on the print bed. So then I went to these square ones. Now these square ones worked pretty well, except I had an X in the middle. And the X in the middle meant that one of the directions created an overhang. And they weren't really deep enough because I couldn't put sticks in from both sides. So then I ultimately ended up adding this block on the side. That way I have more material so I can put a stick in from each side at the same time. Even if I'm putting a stick in from just one side, it holds it very firmly. And I eliminated the cross because that eliminated an overhang. So this prints just like this. Let's look at a picture in the slicer, and it prints perfectly. So I hope you found this enjoyable. I will tell you, my grandchildren love playing with these Popstick connectors. Well, folks, I hope you learned something today, a little bit different type of lesson today. And if you did, make sure you give me a thumbs up, you subscribe to the channel, you recommend it to everyone you know. Go to forum.drvax.com to discuss this with all your friends and accept the challenge and try to make better Popstick connectors. And let's learn something together.